And next up, we have Ariah from Gyroscope. So please welcome Ariah from Gyroscope.
Thanks for the welcome. I'm Ariah Klages-Mundt, and I'm going to talk today about addressing Oracle risks using the consolidated price feed that we've designed for Gyroscope. So the motivation here for us is that we're building a new stablecoin, and stablecoins need Oracle systems. A little bit of background on Gyroscope quickly is that we consider Gyroscope a new set of infrastructure that unlocks a new third path between algorithmic and centralized stablecoins. And so what we're making is a new, more resilient stablecoin called the Gyro Dollar, or GYD. And there's already a proto system that's live on Polygon now, and we're gearing up for mainnet launch later this quarter. Overall, Gyroscope can be thought of as a number of different pillars in the tech stack that allow better risk management and better handling of contingency situations. And the part that we're going to focus on today is the redundancy part around price feeds and a little bit about the circuit breaker system. So to back up just a little bit, the Oracle problem as we see it is basically that financial contracts require secure data feeds. And the natural question is, how do we build these in a resilient way? And this isn't a unique problem to blockchain at all. So an example is what happened in the LIBOR manipulation back in 2003 all the way to 2012. And in this situation, you had a number of big banks, including Deutsche Bank, Barclays, Citi, big names like JP Morgan too, and they were manipulating interest rate data that was used in a large amount of contracts. So this included like mortgage contracts. And essentially what was happening is that banks were submitting incorrect data to force the LIBOR measure to their advantage. And it got to the point of being so bad that individual traders were asking for very specific changes, manipulations to the LIBOR to make individual positions profitable. And so the main takeaway here is basically that this is a known issue, even when you have very high reputation entities. And the natural question is, can we do anything better, make more resilient price feeds for DeFi? And in the blockchain application, what we need is really price data. And there's some fundamental reasons why this can be hard. So some price processes take place off-chain, for example, on centralized exchanges mainly. And further, these processes involve off-chain assets. For instance, USD. And these assets don't exist on-chain, and so fundamentally you can't really observe trades with respect to those assets on-chain. And it's a bit dangerous to just kind of use a stablecoin as kind of like a placeholder for USD to be able to observe these sort of processes on-chain. And an example is what happened to USDC back in this March. And basically, USDC depegged and caused a lot of other stablecoins to depeg as well. And so if your Oracle was assuming that USDC was $1, of course, your whole system would be messed up. And so what we need is oracles that, on some level, at least in some places, that bring these prices on-chain. And an issue is that the Oracle price correctness can't really be, in principle, verified. We can only really authenticate that the data is coming from who we think it's coming from, basically by checking a signature. So this is the Blockchain Oracle Summit, so I'm not going to focus too much on this slide. But just as a reminder, just a large part of DeFi does rely on oracles, either directly or indirectly. And stablecoins is probably like the biggest key point here. Like, you can't really make a decentralized stablecoin that is kind of targeting a dollar unless you actually know what assets are worth in terms of a dollar. And the current Oracle approaches come with their own sort of like challenges and different sort of security models. We have centralized oracles where you have to trust the centralized provider. We have sort of like medianizing among different centralized providers. So something like Chainlink. But you still kind of have the fundamental trust model of like a trusted multisig, and that multisig could potentially collude, like what happened in the LIBOR manipulation. You can also look at DEX trades and look at time-weighted average prices. But again, these you can't necessarily get the right quote asset from these. They can still give you some information, but they can be wrong because it's the wrong quote asset. They can also be manipulable, and they can also be slow because, I mean, they're time-weighted averages. And then there are some other models, but around like betting markets and data derivatives, but they have sort of the same sort of fundamental issues as we were seeing with the centralized providers as well, and that you could still kind of like collude in the system. You can't really prove that the output of the system is the true price. And so in this talk, I'm going to walk through a few topics. One is a new Oracle approach that informed what we built. And the background for this is that the aim is to validate the likelihood of Oracle integrity using the information that you can see. And then I'll walk through our first instance of this, which is Gyroscope's consolidated price feed, talk a little bit about kind of research into some new data sources that could feed into this, and then touch a little bit on some future directions that this could go in. So the new approach we're talking about is validating the likelihood of Oracle integrity given other observable variables you can see on chain. And so overall, the flow kind of looks like this. You have input data, can be on and off-chain sources, and it can be price and also possibly non-price data. You have some mechanism, which is what we're aiming to design. You can kind of think of this mechanism as a system of no arbitrage conditions on the input data, and so kind of like checking if things are out of balance, basically. And then your output data is not only a set of price estimates, but also a signal about the likelihood of Oracle integrity given what the mechanism is doing. And so you can kind of think of this as treating Oracle data as like candidate prices instead of true prices necessarily. And you're consolidating with on-chain data. And the goal is to be fast, but with some extra safety guarantees on top. And another way you can think of this is that protocols today, or protocols can use this signal of Oracle integrity as a new bit of information. And they can use it to improve security. So you can think of this as like a fundamental trade-off between liveness and economic security for a protocol. And the current state is basically over-optimizing for liveness, basically always taking the Oracle price as true, and so having questionable security. But there's a whole spectrum here, and you could design your protocol to take this signal into account and sort of disallow very risky actions, for instance, when the protocol isn't really sure that the price data is correct. And for Gyroscope in particular, we're optimizing for security here, and perfect liveness for our application, at least, isn't necessarily required. But for other protocols, they may want to consider other points in this trade-off. And so there's a number of sort of design aims you'd want for this system. I won't go through it too much, but generally you want something that's fast, you want something that's usually live, you want to be able to detect stale prices, and you want things that are costly to manipulate. And because there's this second signal of this Oracle integrity signal, you also kind of need to consider if that signal is easy to manipulate or the cost to manipulate it. And you can think of this as kind of like a denial of service vector. And so you need to kind of take this into account when you're designing this mechanism. And this is hard, basically, because formulating these no arbitrage conditions in a way that gets you these guarantees isn't necessarily straightforward. You kind of have to balance the security models of a number of different Oracle types. And you have to cover the corner cases of stablecoin pricing. So Gyroscope's consolidated price feed is the first instance that we put forward of this, kind of like a simple first instance. And so what we're using in this approach is basically forwarding the price estimates directly from the Oracle, but having kind of an extra system below that to do these sort of like no arbitrage condition checks in the consolidated price feed, which then outputs the signal about Oracle integrity. And to keep it simple, this signal currently is just like a 1-0 signal about whether things look consistent or whether they don't look consistent. And we're taking input data, for this first instance at least, from chain link prices, which are quoted in USD. We're also using DEX prices, which are not quoted in USD, and so you, of course, have to handle that case. And then some other trusted signer prices as well, which are quoted in USD, but are, of course, trusted centralized feeds, and then are also exploring some possibly further data sources to include. And you can think of this broadly then as basically there's like a vector of Oracle prices, and this system is basically looking at a solution to a system of equations about these sort of no arbitrage conditions. And there's two main types of checks that we're doing in this formulation. One is what we call a relative price check, where we're comparing the relative prices of two on-chain assets, kind of inferred from chain link prices, and checking against DEX prices. And overall, we're thinking about like pricing a basket of assets. And to do this, you kind of need these relative price checks. You need like each asset to be covered, and you need something that looks like a spanning tree of the different assets in terms of which DEX pairs you need to be comparing against. And so that's part of the calibration as well for this system. And the other type of check is what we call like an absolute price check. And here we're actually kind of like double checking that the overall price level in the system makes sense, because the relative prices you need something that connects back to USD, the like desired quote asset, and the relative prices don't actually give you that, and so you need some extra check on top of it. And for here, we need kind of at least one other data source to check against, ideally many more. And this doesn't necessarily have to be like a perfect data source, but it needs to be some sort of reliable signal overall, and but it doesn't need to be perfect. And this is kind of like at a high level what the consolidated price feed looks like in comparison to what's have been used in Compound, the Uniswap anchored view. And basically, you can think of it as the relative price checks as sort of like a mesh of checks between on-chain assets. And then we're adding in this absolute price check that grounds down to the USD quote asset. And it compares with like the Uniswap anchored view, which is just doing one check, and the check is just implicitly assuming that one USDC is one USD. So the relative price checks are basically against a DEX pair. And when you're calibrating this, you kind of need to consider the manipulation cost and sort of the liquidity in the pair and the range of liquidity for the pair. There's sort of a straightforward way of just like checking thresholds about is it consistent with this or not. And basically, if there's manipulation, the check fails, and we're OK with that. And so you could potentially pay to like manipulate the TWAP price. But as long as the system is detecting that, we're happy that it's at least getting caught. And in terms of just looking at like the history of this, it's been running on Polygon for the proto system of Gyroscope since January, or this has actually been running since September. And here you can see when the ETH USDC relative price check kind of moves outside of the bounds we've been using so far for this relative price check. And so it's something that basically very infrequently happens, that it would naturally come out of the range. And so you don't necessarily come up with a lot of stalls in the system because of this check. And then the absolute price checks is kind of the more tricky one. Because here you need to ground to the USD quote asset, but of course it doesn't exist on chain. And so what we're doing is we're using many different sources here. We're using some DEX TWAPs that basically interpret stablecoins as their own sort of oracles. But in a way that's a little bit resilient to any individual stablecoin depegging, or even multiple stablecoins depegging downward. And then also using some other signed price information into a calculation that looks like this. And this one needs to be just a little bit more complicated because it has to handle more edge cases. In particular, you need to kind of handle the issue of stablecoins possibly depegging, and in particular, like depegging downwards usually. There's also some other sort of complementary safety measures that kind of add on top of this, which basically tries to catch sort of residual risk in case the consolidated price feed in the previous checks kind of doesn't detect a price manipulation. And one of these is an excessive flow rate circuit breaker, which basically looks at how much is moving in and out of the system. And if it goes beyond kind of reasonable limits, it would just automatically pause the system. And then there's some other methods for helping to price, for instance, like LP shares as collateral types. Then I want to briefly talk about kind of aiming higher with this sort of a mechanism. You could potentially use a further array of data sources to help strengthen, in particular, this absolute price check. Because so far, like that absolute price check requires quite a bit of trusted information. The best you can do with the trusted information is just spread it amongst a number of sources. But maybe you can actually bring in some less trusted information to help strengthen it as well. And so this is part of a paper we also published recently. And the main idea is, can you use non-price chain data to help sense check Oracle prices? The aim being that you want to recover some sort of off-chain price signal, but from the non-price chain data, things like mining markets or proof-of-stake markets or gas markets or other sorts of markets that occur on-chain. The overall context is that agents in these markets, they know, of course, the correct ETH/USD price, and that price is presumably informing their actual on-chain decisions in those markets. And so there's some sort of causal relationship here, and potentially you can recover some pricing information just from native on-chain data. And so we looked at this a bit. There's some success in actually doing this, but I'll kind of leave that to that paper. It's not yet at a state where you'd actually be able to bring it into to something in real application. And then I'll cover just a little bit of where you could go with this sort of a mechanism. So there's a few directions we're actually going. One is actually how do you optimally calibrate this thing? And this involves sort of balancing the security models and also sort of thinking about gas costs. And you can actually formulate it as an optimization problem if you really want to go that far. And you can do that using sort of the existing research on TWAP manipulability and sort of cost to manipulate. And another area you can look at is what we were just looking at in the previous papers, expanding the data sources you could actually incorporate into this sort of a mechanism. You can read the paper for some more details, but generally there's some difficulties there in terms of a modeling approach, the best modeling approach, and also being able to access some of this data within the EVM requires a bit of extra work and intense extra work. And you can also look at expanded mechanisms. Maybe you want to actually switch between different price feeds depending on the signal of Oracle integrity instead of making a liveness trade-off. Or maybe you want to actually use this to feed into uncertainty bounds about your prices, and then the protocol could use those uncertainty bounds. And a last area is that you can actually model out the incentives in this system and look at the economics of how does this affect the economics of being an Oracle. And basically an idea is that you can think of the consolidated price feed or something like it as adding constraints to kind of existing models of how oracles work, because they have to. They know that this check would be happening afterward. If they manipulate things too much, they know they'll get caught on chain. And the idea is that this could tend to increase incentive compatibility of an actual Oracle provider. And we have some existing work that we think can be adapted to do this using what are known as capital structure models. These models are for DeFi governance right now, but you can kind of replace the governor role with the Oracle role and then kind of use the same models. And one last area is basically thinking about economically securing Oracle networks. So here, a lot of Oracle networks like Chainlink have been proposing using some sort of slashing condition to economically secure their network. But the current slashing conditions basically suffer the same sort of Oracle problems that we were trying to tackle in the first place, something like the beauty pageant problem. Basically, it relies on the consensus of other node operators but to do the slashing, but that consensus isn't provably correct and could be wrong, and you could kind of collude to do something that's not the correct slashing outcome. And the way we think that these sort of methods can help address that is that you could use it to design an alternative criteria. So in particular, you could make like an optimistic version of the consolidated price feed. And here, Oracle node operators would report both prices and the signal about Oracle integrity, like the 0, 1 about whether the consolidated price feed conditions are violated, but this isn't necessarily executed on chain. But then anyone would be able to prove that this second signal was reported incorrectly, and then initiate the slashing condition, basically, if they did that. So that brings us to the end of my talk. As a quick kind of recap, we see that DeFi depends on Oracle prices, but they're often taken at face value, and we don't think this should be kind of the standard way of doing this in DeFi. We think we can do a bit better. And our solution is the consolidated price feed, and what we're doing is we're validating kind of implied relative prices. We're also looking at like absolute price levels by looking at a number of different data sources and kind of giving a signal about the likelihood of Oracle integrity that can then be used by the protocol to kind of make the trade-off decision about should it be live now or should it scale back risky operations. And it's live now on Polygon, and soon will be on Ethereum as well. And yeah, any questions?